please welcome Executive Vice President of the Microsoft Cloud Enterprise Group, Scott Guthrie.
Well, good morning, everyone, and welcome to today's Data Amp event. Today we're going to be talking about the work that we're doing here at Microsoft to enable you to work with data in incredibly rich ways, and how we're working to enable you to use data to fundamentally transform your business. We've got a lot of great announcements of new products and new capabilities that we're going to be showing for the very first time today, and I'm super excited to get a chance to really walk you through all the great innovation that's coming, as well as about how you're going to be able to leverage it in really a seamless way across literally any type of environment, whether inside your existing on-premises data centers or taking advantage of what the cloud has to offer. Let's start first and talk a little bit about the cloud and some of the exciting things that are happening with that and why it's so important as we think about our data platform and how it interrelates. The cloud is a generational shift in computing that's happening, and it represents major changes for everyone, Microsoft included. And every organization over the next few years is going to need a strategy for how they move from where they are today to take advantage of what the cloud has to offer. Organizations are going to look to adopt new cloud-based productivity and business application solutions that are going to enable their employees to be even more successful and to create new business processes. Organizations are going to look to build new applications that enable them to better engage their customers and optimize the running of their businesses. And organizations are going to look to take advantage of all the new data and intelligence technology that's out there. Things like artificial intelligence, IoT, advanced analytics, and more to really unlock insights about their data and enable intelligent action from it. And they're going to need to be able to ensure that they can manage all of these solutions in a secure way, holistically across both the cloud and their existing on-premises environments. And it's really the combination of all these different scenarios that enable organizations to become more agile, to lower their costs, and really differentiate their businesses. The Microsoft Cloud is unique in delivering in all of these different scenarios. No other company offers the breadth and depth of what the Microsoft Cloud delivers. And we deliver all of this with a global, trusted, and hybrid promise that's really differentiated in the industry. The Microsoft Cloud is a globally scaled cloud platform. And over the last several years, we've been hard at work expanding it to run literally all over the world. The circles on this map here indicate what we call Azure regions, which are made up of clusters of data centers where you can run and deploy your code, your databases, and your solutions. We now have 38 unique Azure regions around the world. That's twice as many locations and countries as AWS. And this enables you to run your applications and solutions closer to your customers' employees than ever before and be able to compete in even more geographic markets. Now, what makes each of these regions really impressive is the sheer size of them. And what I thought I'd do is actually show a quick video of a behind-the-scenes look of what goes into the making of each one of these regions and the tremendous scale and capability that you can now take advantage of. Let's watch the video. So the Microsoft Cloud is optimized for organizations and the startups and software companies that sell to them. And it's not just about technology. Microsoft has decades of experience supporting business and enterprise customers of all sizes. This means we really understand the critical requirements of running software for businesses and governments, including things like certifications, data sovereignty, security, and privacy. In fact, the Microsoft Cloud has more compliance certifications than any other cloud vendor out there. And unlike other cloud vendors, we're also unique in that we're able to deliver our solutions and enable them to be deployed not just in our hyperscale data centers, but also in customer and partner data centers as well. And our hybrid promise extends really across the entire technology stack, from productivity and business applications, to identity directories, to management and security, to core infrastructure, and ultimately to the application, and in particular the data platform itself. And what this means is you look at the technology you're going to see today across our data event, you're going to see us be able to kind of deliver to you a data platform that works, again, in Azure, works in your existing data centers, and works in any other cloud or service provider data center as well. And this gives you the maximum flexibility as you journey to take advantage of what the cloud has to offer, and allows you to use a common set of tools and skills along the way. And all these combined capabilities are leading to tremendous adoption right now of Azure, of our Microsoft Data Platform, and the Microsoft Cloud. 90% of Fortune 500 companies are now running their businesses using the Microsoft Cloud. And this slide here is just a handful of some of these customers that are running on top of Azure and using our data platform today. Now, one of the common themes across all these different companies is how they all are looking to take advantage of data to advance and power their business. Let's dive deep now on the Microsoft Data Platform and how it's providing a unique set of capabilities to do this. Last year, we released SQL Server 2016, which was a fantastic release. It really provides a comprehensive data platform unlike any other offering in the market. And it brought with it major improvements in security, performance, mobility, advanced analytics, and more. SQL Server 2016 is now featured as a leader in Gartner's most recent Magic Quadrant for operational database management systems. Gartner cited us for the completeness of our vision, for our customer and partner adoption, and for our ability to execute. And as Gartner and other industry watchers have noted, Microsoft also now provides the most secure database out there in the industry. The National Institute of Standards and Technology keeps track of vulnerabilities in databases. And according to their measurements, we've been the least vulnerable database, delivering fewer vulnerabilities than Oracle, IBM, or any other provider for the last 7 years. SQL Server 2016 scales from data marts to the world's largest and most complex data warehouse environments. We now have the number 1, number 2, and number 3 TPCH benchmarks in the entire world. And with SQL 2016, we've significantly enhanced our BI and reporting service capabilities. This means you can now publish modern reports on an iPhone, Android phone, or Windows phone, all at a fraction of the cost of competitive solutions. And with SQL 2016, we now support in-memory advanced analytics, enabling you to operationalize predictive analytics directly off of your OLTP workloads. And to do so using R, which is the leading data science language in the industry. And we deliver all of these capabilities with a consistent and high-quality experience, no matter where you choose to store or consume your data. SQL Server today is the only data platform that's available both on-premises and as a fully managed database service in the cloud using Azure. Now, prior to SQL 2016, some of the coolest programming model features of SQL Server, features like in-memory database and analytics support and always encrypted storage, were only available with the Enterprise Edition of SQL Server. This ended up being a barrier for developers and ISVs to be able to take full advantage of what SQL has to offer. One of the exciting things we did last year was to make all of these features available across all editions of SQL Server 2016. This even includes the SQL Server Express Edition that you can use completely for free. And this provides you with an incredibly rich data platform that you can now take advantage of anywhere, with apps deployed in your data center, in Azure, or even other cloud providers. One of the other really exciting things about SQL Server and the SQL Server Data Platform is that we're now making it available for use not just on Windows Server systems, but also now on Linux systems as well. Starting last year, we began shipping our CTP previews of SQL Server on Linux, as well as SQL Server running inside Docker-based environments. And these releases provide the same data engine and all of the rich programming capabilities that SQL Server on Windows delivers. And this now enables you to use SQL Server literally anywhere. And to show off just how easy it is to get started with it, I'd like to invite Laura on stage to give us all a demo. Here's Laura.
Thank you. Thanks again. It's great to be here to show you how easy it is to get up and running using SQL Server on Linux. To start, I've already got Docker installed and running on my Mac, and I'm simply going to pull the latest image from the repo. And once I've got the image downloaded, we're going to just light up our SQL container by issuing Docker run. We'll accept the EULA, set the password, set the ports, and that's it. From here, we can just make sure we got our Docker container up and running, it's alive, and I'd like to just connect into SQL Server, so we'll just come in here and pass in the username and password that we specified. And we're in. Just to make sure that SQL Server is running, we'll just do a quick little test. And there we have it, SQL Server running on Linux. Now we know that SQL is working, so what I'd like to do is just make sure that I can connect from external applications. To do that, we will come over here, and I have built a simple application with Node.js. SQL Server supports all the major programming languages, including PHP, Python, Ruby, Java. My Node.js application is using the tedious drivers, and it will just respond with connected once it's able to reach SQL Server. So I'll come back in here, and let's just execute our program, and we're connected. So how quick was that? In just a few seconds, I was able to install and connect to SQL Server. And the best part is, this is the same SQL Server we know and love. It can support all of the most demanding application requirements. It includes in-memory, column store, the best set of security features in market. So download SQL Server on Linux today and start building your apps.
So up to now, we've been referring to the next version of SQL Server simply as SQL Server vNext. And today I'm really excited to announce the official name for it, which is SQL Server 2017. SQL Server 2017 brings with it a host of additional updates that we'll be going into much more depth on today. These include great enhancements to our core database engine, as well as a host of new scenarios that we're enabling with it, including now graph database support, even richer machine learning support with both R and Python languages, as well as unparalleled performance with our new adaptive query processor. And what's great is that we'll be releasing all of these SQL Server 2017 capabilities simultaneously on Windows Server, Linux, as well as Docker-based systems. And what's really great is that we're making available the CTP2 release of SQL Server 2017, which includes a production go-live license, meaning it's ready for production use today. SQL Server 2017 is now the most secure and most intelligent database on the planet, and now provides really unlimited ultimate flexibility. Let's watch a quick video of one startup who recently switched to SQL Server and why they chose to do so.
Bear Stearns shares are down 90% this morning, and it's not just Bear. Pretty much
working at Bear Stearns in 2008 during the mortgage meltdown was really an eye-opening experience for me, because it was clear that even one of the largest investment banks at the time didn't have much transparency at all into how much they owned or even what those assets consisted of. DV01 brings institutional investors transparency into the consumer lending markets, handling everything from data normalization, data management, to reporting and analytics end to end.
We started out small on AWS and RDS, and just like most startups, we ran into a lot of scaling challenges. Switching to SQL Server was a game changer for us because the latency went from tens of seconds down to less than 1 or 2 seconds for most of our queries. We're looking to move into SQL Server 2017 on Linux as soon as possible. The decision was a controversial one. Our engineers came from an open source background, and we're an open source shop. But ultimately, what ended that debate was the performance benchmarks.
Microsoft Machine Learning is a great tool to help our organization, and this allows us to separate that finance and tech background and let the finance people focus on what their expertise is, which is operating on financial data.
We think Microsoft Machine Learning can solve most of our problems. It provides a parallelized version of many of the popular algorithms that make the iterative process of modeling very efficient.
Starting a company is tough. There's a million things that we have to worry about, but it's been really comforting to have Microsoft in our corner. There's many things that contributed to the financial crisis, but we definitely believe that lack of transparency for investors was a big one and a problem that we're tackling head on with DV01.
One of the things that makes SQL Server unique is that it's the only data platform today that's available both on premises and as a fully managed database service in the cloud using Azure. Our Azure SQL database offering is a fully managed SQL Server as a service. And this enables you to easily stand up a new SQL database in Azure in under 60 seconds and have it be highly available, durable, secure, and fault tolerant without you having to configure or manually administer anything. And you can leverage Azure's global footprint to run your SQL databases now literally anywhere. And you can also configure databases to use automatic geo-replication support, so you can actually enable them to run simultaneously in multiple geographies for even better performance, latency, and high availability. And in addition to geo-replication support, we provide built-in backup and point-in-time restore capabilities, automatic performance tuning support, and threat detection capabilities that enable you to run your systems even more securely. And best of all, you get all of these capabilities without having to manually manage virtual machines, to have to worry about patching your infrastructure or tuning and configuring it in a manual way. Our SQL Database as a Service offering takes care of all of that for you. I'm excited today to also announce a new Azure data migration service that we'll be releasing, that it's going to make it even easier for you to migrate your existing databases to use our Azure SQL Database as a Service. This data migration service streamlines moving existing database systems to Azure and provides a fully automated workflow to do so, both for existing SQL Server databases as well as for non-Microsoft database platforms as well, including Oracle-based systems. And this new data migration service is going to help you further accelerate your journey to the cloud. And what I'd like to do is invite Akash on stage to show off a demo of how you can use it. Here's Akash.
Hello everyone, my name is Akash Warenkar and I'm an engineering manager in the Cloud and Enterprise division of Microsoft. Today, I'll give you a sneak peek into a new Azure service that enables frictionless migration from on-premise SQL Server and other databases such as Oracle and MySQL to Azure SQL Database. So here's what we will do. I have an on-premise SQL Server instance with 7 databases in it. 2 of them are enterprise Stack Overflow databases, which power the internal Stack Overflow application. I've connected to an Azure SQL Database instance, and you'll know more about this soon. What we'll do is a live migration of these 7 databases from the on-premise SQL Server to Azure SQL Database using the new migration service. So let me head over to the portal. You can create a new instance of this migration service using the new service creation experience in Azure. For now, I have pre-provisioned an instance of the migration service. Let's create a new migration project. Let's call it get to Azure. As source type, we support SQL Server, Oracle, and MySQL. Let's select SQL Server. Azure SQL Database is our target type. Let's start. Based on various customer engagements that we had and the learnings that we got from it, we invested heavily into simplifying the entire migration experience. You don't have to go to various portals or download various tools to move your schema and then your data. Instead, this is a one-stop experience where, in 5 steps, we will migrate your data as well as your schema and guarantee consistency. So let's start. Step 1, let's enter the target server details. This is the same SQL Azure Database instance that I showed you before. Let's choose SQL Authentication, and let me give the credentials over here. Let's make sure that the connection is encrypted. Step 2, let's connect to the source SQL Server instance. This is the on-premise SQL Server instance that has the 7 databases which we will migrate. This time, let's select Windows Authentication, and let me enter my domain username and password. Let's make sure that the connection is encrypted. Step 3, let's select the databases that we need to migrate. In our case, we'll select all the databases. Step 4 is where we enter certain migration settings that are required by the migration workflow, such as it requires a network location which it will use to take the backups from the source database, and of course the credentials to access its particular network location. Step 5 is just to verify the summary. So our target server is Azure SQL Database, our source is on-premise SQL Server, and we have selected all the 7 databases to migrate. So let's run the migration. As you can see, the service has already started migrating all the databases in parallel. The beauty of this particular migration service is that the instance of the service is created inside a virtual network in user subscription, so data never leaves the customer boundary. So let me refresh, and as we speak, most of the databases are migrated, except one, and there you go. Even all the databases are migrated. Let me go back to Management Studio and just refresh the list of databases. And there you go, all 7 databases in Azure. So now only thing that I need to do is go to my application, change the connection string to point to this new instance, and my application has to work. So what you saw today is a new service in Azure, the migration service. And we followed a very simple 5-step process and migrated from an on-premise SQL Server instance all the databases to Azure SQL Database. And the only thing that is left right now is to go to my application, change the connection string, and the application definitely will work. Thank you.
I'm also excited to announce today a number of new capabilities that we're also going to be adding to our existing Azure SQL Database as a Service offering over the next couple months. These new capabilities we're adding further increase the surface area of our Azure SQL Database service, and collectively have the goal of enabling you to move literally any existing SQL Server that you have on premises to run using the SQL Server as a Service offering within Azure with no database or code changes. The updates we're announcing today include adding things like SQL Agent and Service Broker support, extensibility support for using CLR as well as R-based services within your applications, the addition of the existing SQL Profiler and additional DMV and Xevent support so that you can optimize cloud databases using the same workflow that you do today on premises, as well as native backup restore, log shipping, and transaction replication support. And collectively, all these additions make it possible to literally migrate any SQL Server to Azure with no database changes, and to take advantage of the tremendous TCO improvements that our SQL Database as a Service offering provides. And they're going to enable you to build great data solutions even faster and leverage the full power of the cloud as you do so. Now, more and more data is being created and stored in the world. And the ability to use software to work with this data and turn it into even more intelligent apps is absolutely enormous. Well, one of the great services that we now have available inside Azure is our Azure Data Lake offering. With Azure Data Lake, we now enable you not only to store relational data, but you can actually store literally any form of data in any volume or variety within the system, scaling up to literally hundreds of petabytes or even exabytes of storage and literally trillions of individual files or data entries. And you can create a data lake literally in seconds. You can put any amount of data within it. And then the beauty is you can actually leverage SQL and a particular SQL syntax that we've created called uSQL to basically run jobs against all this data, both structured and unstructured, integrate it with databases like SQL Server and our SQL Database as a Service offering, and really create deep insights that you can use to power and run your business. Azure also provides a rich set of data and analytics services that enable you to reason over this data that you're storing and create custom machine learning and artificial intelligence models from it. This gives you the ultimate power to actually train your business based on the data that you're storing and do really rich insights from it. And in addition to providing sort of these lower level data platform and machine learning services that you can leverage, we also now provide a rich set of pre-built cognitive APIs on top of our Azure platform as well, that you can very easily use and integrate inside your databases as well as within your apps without having to be a data analytics expert. And these cognitive services include capabilities like visual and text analysis, speech detection, emotion detection, and a whole lot more. They make it possible to literally add richer intelligence into any application out there. I'm really excited to announce today the general availability release of several of these new cognitive service APIs, including our Face API as well as computer vision APIs. As I mentioned, you can literally use these APIs from within any application, including from within your actual database itself. What I'd like to do is invite Danielle here on stage to actually show off a demo of how you can leverage the Azure Data Lake service, these cognitive service APIs, to build a really powerful, rich workflow that allows you to reason over data. Here's Danielle.
I'm excited to be here today to tell you about how we're enabling intelligence at scale. Now, in this Power BI dashboard, I'm actually visualizing over 2 petabytes of Microsoft customer support data. Now, the secret to delighting a customer is to listen to them. This is really straightforward to do when you're working one-on-one with a customer. But when you have over terabytes or even petabytes of Microsoft customer support data or your own customer support data, how do you do that? It becomes a lot more complicated. You might have disparate data that you need to merge in together. You could have raw text that you need to extract using cognitive capabilities. Now, what I'm going to show you is how we're actually doing that using Azure Data Lake. You see, for example, in this Power BI dashboard, I'm visualizing the sentiments of certain products, extracting key phrases from text, and even forecasting out into the future what our support call volume is going to be. So let me switch to an architecture picture to show you how this is working. So here we're using Azure Data Lake, which allows you to run massively parallel processing programs in uSQL, in .NET, in R, and Python over petabytes of data. You can even connect to SQL Data Warehouse or SQL Database and do through federated uSQL queries. Additionally, through Polybase over Azure Data Lake, you can look at your Azure Data Lake tables just like they're a table in a SQL Data Warehouse. And then you can use Azure Analysis Services in order to query those data in through a Power BI, for example, and look at that data with near human latency. So now I'm going to show you what's under the hood. Here, I'm not going to go into depth of what these queries look like. I just want to give you a flavor of what they are. So in this example, I'm using a uSQL query. Now, if you know SQL, you know uSQL. Observe how simple it is. I'm doing a count, for example, of our products and getting a tally of that. Additionally, we can use cognitive services, which are built into Azure Data Lake. Not only do we have those cognitive services APIs available to connect through the API interface, those are also embedded within Azure Data Lake directly. So those cognitive capabilities can be run natively within Azure Data Lake. You see, for example, that I'm using a key phrase extractor on top of that Microsoft customer support data. So being able to do cognitive capabilities at petabyte scale. In this example, I'm actually using open source R to forecast that call volume and actually using an ARIMA time series forecasting model, which is what was visualized in Power BI before. Additionally, you can actually visualize the data in Azure Data Lake like it's a table through Polybase in Azure SQL Data Warehouse. So you see, for example, that I'm selecting a certain number of rows from our Azure Data Lake table. So let me switch over to the Power BI dashboard. So in this dashboard, I'm visualizing the API requests that are coming out to a new product. I'm visualizing the requests by time period as well as the color here, which is the latency of those requests. So we can see the number of requests over time, as well as the red represents periods of time where things are really high latency. So let's zoom in where we see a lot of requests coming in to find out what could be going wrong in a certain time period. And let's zoom into a particular data point that has a really large latency. We find out what's going wrong. Again, billions of rows, but near human latency that I'm drilling down here. Now you see, when I drill down to one of the lowest levels, I actually have a lot of green, so a lot of things going right. But if I scroll over, I see a couple time periods where things are going wrong. I can actually click on this and see where those requests are coming from. Now I can even drill down and see those individual records or data to really understand what's going on in this particular instance. Then I could work with this customer and actually change how they're using our service or work with the engineering team to improve our products. So with Azure Analysis Services, we can do near human latency to understand lots of data, really bringing intelligence at scale to your data. Now in this demo, I showed you how you can use Azure Data Lake with big cognitive capabilities to understand natural language capabilities, as well as R to do things like forecasting or support call volume. Additionally, using Azure Analysis Services, which has an in-memory column cache to allow you to do near human latency to drill down on that huge data, visualized through Power BI. We're looking forward to seeing what you can do with this new breed of intelligent services. Thank you.
So Danielle just showed you a fantastic demo there that really shows you pulling together a lot of our different data platform assets and really demonstrates how you can use our platform and all the rich capabilities of it to really get insight from your data and ultimately be able to turn that into intelligent action that you can then drive your business from. You know, one of the services that she showed in addition to the Azure Data Lake and cognitive services was our new Azure Analysis Services. Service, which I'm really excited to announce is available in general availability form today. And with Azure Analysis Services, it helps you basically transform these complex data that you're storing from lots of different sources into a BI semantic model so that users in your organization can easily gain insights by connecting to the data models using the tools that they already own and use today, things like Excel, Power BI, and just even custom reporting to perform kind of ad hoc data analysis at speed and to be able to really get deep insight from your data. And this is sort of the first offering of its type provided in the cloud, and we're super excited to see it available in general availability form today. So the opportunities for all of us in this room to transform our businesses using data have never been greater than they are today. And with a Microsoft Data Platform, we're giving you the tools to really drive insight from your business, turn it into intelligent action, and really fundamentally transform your success and how your business functions. And to do this with maximum flexibility, with the ability to basically take data that you're storing in the cloud, connect it with data that's running on premises, to be able to do it with Windows Server, to be able to do it with Linux, and to be able to tackle literally any type of data opportunity out there in a really rich way. And with the tools that we're providing, we really think you're hopefully going to be able to build even better database solutions that can really fundamentally change your businesses and really reinvent the world. What I'd like to do is we're going to have Joseph come on and go into a lot more depth about our data platform and a lot of the big announcements that we made today. And you're going to actually see, never click down all you can do with both SQL Server and with our Azure-based data services. What I'm going to do first, though, is show a quick video of one of our customers, Rockwell Automation, that's taking advantage of all these capabilities today to fundamentally transform their businesses and give you a sense of just what all the possibilities are and how to use it. Here's Rockwell.
We wanted to make it really easy for our customers to get meaning out of their data.
A lot of industries have data, but they haven't been actually able to make the data work for them.
Any producer is competing against great competitors from around the world, so they constantly need to innovate to do more with less.
Shelby is FactoryTalk Analytics for devices.
Shelby actually allows us to put a data scientist in a box.
It is an information appliance that our customers can deploy in their manufacturing operation to analyze the data that's coming out of the device. We use Microsoft Cognitive Services to train the bot. This also uses machine learning. We're pushing up every event that Shelby sees and doing summary calculations in Power BI. Great Lakes Brewery was one of our first beta customers.
We were able to help them by finding out how their assets were performing, how healthy they were, and allowing them to do it in as easy a fashion as possible.
Implementing Shelby was super easy. It took about 3 minutes, a couple of mouse clicks, and we were analyzing problems that we were then able to solve immediately. Technology allows our brewers and other process individuals to stay focused on the craft of the product rather than the process.
Most of our customers don't know that they need Shelby until they get Shelby. One of the things that we've been experimenting with is attaching the bot to a voice interface like Microsoft's Cortana.
There are 2 drives that need maintenance.
So a customer can find out the status of their system no matter where they are without taking their hands off their work. When we show our customers, jaws drop. People are astounded by the bot.
Being able to use the Microsoft bot framework to make our product as easy to use as possible has just been amazing. It is an infrastructure that we can use immediately. We don't have to set up our own cloud computing infrastructure. Azure does all that for us. We can put our own industry knowledge on top of it and make our customers more productive.
Our customers are seeing a new Rockwell. New innovation with Microsoft is showing them that we are evolving to create positive outcomes for their businesses.
All of the devices are online, and there are 3 that need maintenance.
What I'd like to do now is invite Joseph Saroche, who leads our data team, on stage to go much deeper into the individual technology and really show you what you can do with it. Here's Joseph.
So I'm here to tell you about some exciting innovations in data and intelligence. You know, our world is rapidly undergoing an enormous digital transformation. Everything is digital data. What we observe, what we record, and how we act. Everything is being digitized. And everything becomes a data analysis problem. Understanding the world around us, understanding the world inside us, and understanding how we can make this world a better place for each and every one of us. So whether it's unraveling the mysteries of the universe, or curing cancer, or making the world a more sustainable place for us to live in, the answers to those problems lie hidden in vast amounts of data that we are now able to collect. And it's the same in business and government. With platforms and tools to explore that information that is latent in the data, we stand to make enormous progress. And today, there is an enormous convergence happening. There is a convergence of cloud, data, and artificial intelligence that is coming together. And that's revolutionizing how we transform that data that we collect into insights and intelligent action that change our world. With the limitless computing power of the cloud, the Internet of Things, and the new capabilities like machine learning and AI, organizations can now build and deploy intelligent applications that change their business and change their operations. These technologies have the power to disrupt almost every industry. Entire systems of production, management, and governance are being transformed. Let me give you an example. Consider Cochrane. It's a global independent network of researchers, professionals, patients, and caregivers working to transform healthcare with data analysis. So now let's hear from them and see the video.
Systematic reviews summarize all the best available research evidence to inform decision makings in health. Research had been done that looked at whether steroids were helpful in improving the maturation of premature babies' lungs. The reviews showed conclusively that giving steroids saved lives amongst premature babies, and that has probably saved many thousands of lives.
And for a typical review, we might well have 20,000 citations to sift through as a team.
It can take 2-3 years to complete. Project Transform is an artificial intelligence project that brings together the technology that's able to manipulate and analyze data very efficiently.
We've been able to create a data set that can train the machine to help us do this task so that we can then better direct human effort where it's most needed.
We're using Cortana intelligence to enable us to develop and deploy these machine learning applications in the cloud. We've got a series of different classifiers where we narrow the scope of what a particular citation is looking at. What we're able to do is to be able to identify the research which is likely to be relevant for a particular review. I'm using Azure Machine Learning Studio to develop and deploy web services which make these classifiers available. We're then able to visualize the performance of the classifier across the set of studies. We find most of the relevant citations much earlier in the process.
What I love about all of this is that it's all about that partnership between the human and the machine.
Artificial intelligence will allow us to answer more complex questions more efficiently and with more precision, improving decision making and therefore helping patient health.
Microsoft's data platform is built for the needs of such leading customers in every industry. Now, we learn from them 3 important themes for data platform innovation: intelligent, trusted, flexible. First, intelligent. We learned that it's critical to bring intelligence to where the data lives and is generated, in databases and applications. And that's incredibly important to customers because customers find it increasingly hard to move vast volumes of data and manage secure, compliant, data-driven applications. Second, trusted. We have learned that it's critical for data platforms to provide state-of-the-art features for managing security and compliance. Data is the most strategic, most high-value asset for our customers, and they want it safe. Third, flexible. We have learned that our customers work in extremely heterogeneous environments. They heavily leverage open source innovation, and they need flexibility when it comes to the choice of the platform, programming languages, and data infrastructure. So these are the 3 themes: intelligent, trusted, flexible, that are the foundation of our data strategy. In the rest of my talk, I will share some of the key innovations we are making along these dimensions. Let's now talk about the first theme, building the intelligent data platform. And this is very exciting. Microsoft has been investing heavily in machine learning and AI for over 2 decades. We have over $12 billion in R&D every year. We can bring all of these innovations into our data platforms to enable you to build the next generation of applications. And we want to make it today very easy to deploy advanced analytics and intelligence in these applications by integrating that into the data platforms. So let me talk a little bit more about it, about bringing intelligence to where the data lives in these data platforms. Why do that? Here's the motivation. In the past, a common application pattern was to build and host statistical and analytical models and business rules associated with them outside the database in an application layer specifically built for that. Well, this meant that the application layer had to perform a tremendous amount of heavy lifting. Fast data extraction, concurrency, high availability, resource management, security, access control, compliance, manageability, the list goes on. It is a lot of heavy lifting that you have to build independently of the database layer. But guess what? A modern database platform already gives you all of that. It already does that heavy lifting. And now we are exploiting that capability already built into these to make it trivially easy to host machine learning applications. So you can have AI in a performant, multi-threaded, distributed way at scale executed directly in the database. This includes Microsoft machine learning algorithms and the leading AI research that is coming out of Microsoft Research, and even open source R and Python. All of this can run in the database now, leveraging the power of the database management system. And this is available to you both on premises and in the cloud. Yeah, that's right. No one but Microsoft can do this for their customers. Let's talk more about how we are bringing intelligence to your databases. Earlier today, we announced the Community Technology Preview 2, CTP2, of SQL Server 2017, formerly known as SQL Server vNext. It's very exciting. This is the most secure data platform with built-in intelligence for all your data. It's on Windows and Linux, including Docker. It provides unmatched TCO with everything from BI reporting and now AI built in. There are 4 things in particular that I'm excited about sharing today. First one, graph processing. Graph processing is important for fraud detection, social network analysis, and modeling IoT networks. That's where a lot of modern data is being generated in cutting-edge applications. So the next version of SQL Server will support graph objects and graph queries to efficiently model and analyze such data. That opens up a whole new set of possible applications that you can efficiently build on the SQL Server data platform. Second, adaptive query processing. It learns from prior query executions and optimizes for the best performance. So now you have a learning database that tunes itself to be even more performant as it is used more and more. Third, we have made some incredible strides in extensibility in SQL Server. And I should spend some time on it. It's very exciting. It now supports executing of Python, and a query, a SQL query, can even mix R and Python code. And this is incredible extensibility. You can install your own Python packages and run arbitrary analytical computations close to the data in the database. And then 4, using all of that extensibility, we have made some incredible advances in incorporating AI into SQL Server. We have added in some of Microsoft's most advanced ML algorithms into SQL Server with GPU support. This is super exciting. SQL Server is the first commercial relational database management system with deep learning. And now you can use the latest deep learning frameworks like Cognitive Toolkit and TensorFlow to run deep learning models against data that live in the SQL Server database. You can deploy these models without data extraction out of the database and get incredible simplicity when building highly available, secure, compliant, and high-performance AI applications. The best way to understand all this power is really to see it in action. So now let me invite Rohan Kumar, the GM of the Database Systems Group, to show you an exciting demo of this new capability. Rohan?
Thank you. All right. So thank you, Joseph, and hello, everyone. I'm extremely excited to show you the first commercial database with built-in support for AI. More specifically, I'm going to show you how to build and deploy Python applications in SQL Server. And not just any Python application. I'm going to show you GPU-powered deep learning application running in SQL Server that actually does classification of medical image data that is stored inside SQL Server as well. Deep learning and AI are changing lives. Cancer is one of the leading causes of death here in the United States, and the costs are in billions of dollars. Early and accurate detection is key in improving patient outcome and reducing these healthcare costs. Increasing the accuracy and detecting it early can be done by augmenting medical judgment, medical decision making, by using deep learning technology for doing medical classification, image classification. Now let's get going with the demo. All right, so what you see on the screen is a web application that you find in a radiologist's office. So this, I'm logged in as Dr. John T. And every morning I come in and check the reports of some of my patients. I'm particularly interested in looking out for my patient, Anna. So I type in a name in the application and I see basically a bunch of statistics around her medical history. What you see on the right-hand side of the screen is basically the CT scan images, active images of her lungs. Now, based on the analysis of the scan, the application is going to determine the probability of Anna getting lung cancer. So let's go click on the Analyze Scan button to see what the result comes back. What's happening in the background when I click the Analyze Scan button is basically the deep learning model is actually working against all the CT scan images of the lungs images of Anna to figure out the probability of her having lung cancer. And here's where you see the prediction came back with a 55.48% probability of her, which is pretty high. Now, what does it take to build a deep learning system? Let's take a look at that, which is behind an application of this kind. What you see on the slide here are the two main steps in building a deep learning system. The first step is what's called the learning phase, where we take the images, the raw images of the CT scan, and pass them through a process called featureization, which results in a bunch of numerical values for certain features that are used for classification. Those numeric values of features, along with some label data that was manually created, is used to train the model, the classifier model. In the scoring phase, the patient's images are taken, and they again pass through a featureization process, and based on the feature values, they're actually scored against the model that we trained in the first step to determine the probability of the patient getting lung cancer. Now, how do you build an application of this kind? It's actually a fairly complex process to build an intelligent application. There are three main challenges. The first one is to build the intelligence inside the application. The web developer, in this case, had to work with the data scientist, which both of them use different tools, different languages to coordinate, and even happen to be in different organizations. That's very complex. The other challenge is to essentially move the data from the data platform it's stored on to the intelligent application, which effectively means everything around compliance and all could be at risk. Security, governance, etc., which was there in the data platform. And even if the first two challenges are actually met, there is the third challenge of actually migrating the high volume of data, which is very, very hard to do. So typically, the data scientists take a very small sample of the data, which again lands up impacting the accuracy of the model. But for the application that we built, we didn't have to face any of these three challenges because we built it on SQL Server. All the data, the intelligence, and the models that you saw that go into building the deep learning system are integrated deep inside of SQL Server. It's all built in. All that the application had to do, the web application in this case, is issue a store procedure call that essentially came back with a result, which is the probability of the patient having lung cancer. That is it. It really sort of came down to just a single store procedure call that the application had to make. All the intelligence, all the data, all the models that we created to back up this application were all built into SQL Server. All right, now let's go take a look at the code itself. All right, so basically what you see on screen is Visual Studio Code hosting the application code. And the thing I want to highlight is there's a lot of code that basically is just around the UX of the application, etc. But the intelligence of the application is just a single line, which essentially invokes the store procedure inside SQL Server. That's it. In fact, as an application developer, I didn't have to worry about understanding how all that intelligence is getting built. All that is taken care of me by somebody who already built the deep learning model and operationalizes within SQL Server. That's how easy it is. Now let's take a look at what's happening, the magic that's happening in the back end. For those of you who are familiar with our services in SQL Server, what you're seeing in the Management Studio must be very familiar. Effectively, we have SP execute external script, which is how you sort of define store procedures that execute our code with SQL Server 2016, now have support for the Python language. Everything else remains the same in terms of the parameters. The extensibility, the trusted extensibility model that we added to support R now essentially supports Python as well. Very, very simple. Now let's go back and sort of take a look at the actual T-SQL code with Python built in that was used to generate the features. Remember, feature extraction is the very first step that we go through. So let me sort of bring up the store procedure over here. Again, what you see on the screen is basically a few lines of code that do a lot of deep learning magic, right? The first one, the thing that I'm sort of getting is essentially a model that has already been operationalized, already been trained and hosted in CNTK, which is an open source library from Microsoft for deep learning that I'm sort of using to install inside SQL Server. So the first step is to get all the scans from the patient images. Again, pretty straightforward. The second step essentially is to manipulate these images. These images are actually pretty large in size, but you don't need all that data. So there is OpenCV is an open source Python library that can be used to sort of reduce the size of the images while maintaining all the value. So again, another point to call out essentially is it's so simple to basically host all the open source Python libraries right inside SQL Server. We just did that with the manipulated images using OpenCV. The next step essentially is the feature extraction. Now, it seems there's a single line, but here's where there's a lot of magic of CNTK running on GPU on the local machine, right? So this is about 1,500 patients worth of data is what we have back in the application, and that comes to around 250 or 300,000 images. Going through the entire feature extraction phase takes about 53 minutes because the code essentially is using the amazing amount of parallel processing power inside the GPU. Just for comparison, if the same thing was done without using GPUs, it would have taken 30 hours. That's 30x longer. So just the power of GPU and CNTK, the library using it, reduces that by 30x. And finally, once you get the features extracted, you insert the features into the table. So that sort of completes the featureization phase. Right. Now let's basically take a look at the next one, which is the training phase. Here's actually very simple. So the features that got extracted essentially are split into two parts. The first one is essentially used in combination with labeling. It's a manual step where, think about in our scenarios, the doctors are using their judgment to look at the picture of the lungs and determine whether the probability of cancer is high or not, right? So that's the labeling phase. You basically take the label data, take the feature extraction data, train the model, and verify it using the manual labeling. And the whole process sort of goes into training the model. The classifier, right? So the classifier, again, here is an open source machine learning model from Microsoft LightGBM that we're using. And once it's trained using the label data and the feature extractions that we did, you insert the model back inside the database. Again, fairly straightforward. Now, the final step is the scoring one, where we actually use new images of patients, send them through the feature extraction phase, again, what we've done, and then classify them by scoring them against the LightGBM model that we trained in the previous step. All right, so sort of take a look at how simple that is. So patient ID query gets the patient ID from the information that's already stored inside the database. For this particular patient, take all the scanned images, send them to the feature extraction phase. That's the get feature step. And then finally, again, get the model out. Remember, we sort of trained the model and installed it inside the database. We're getting that out. And finally, a simple check, which is prediction based on the model that we trained and the feature set for these set of images for the patient, is the probability of cancer. Now, this essentially is the store procedure that the application called. All the magic, again, of creating the model, storing the data, storing the models, is all happening inside the database. And from the application side, we're just calling it. So what you've basically seen here essentially is how easy it was to basically go embed deep learning based on Python code inside SQL Server using the same extensibility model that we had built for our services. We're now getting Python in. Now let me actually show you how we are able to actually host other open source Python libraries, deep learning libraries as well. So what I have on this VM essentially is TensorFlow installed, and it's basically a very simple application that just hosts TensorFlow and does a hello world. Let's go and execute that and see how that works. Okay. It's, again, there you go. This is effectively TensorFlow installed on the machine, hosted inside SQL Server to basically do deep learning based applications. Now, finally, I just basically want to close with the key points that you just saw. First thing is building enterprise-grade AI apps using deep learning and based on Python is extremely simple now. It follows the same extensibility model that we built with R. Again, since the data, the model, the intelligence is built inside SQL Server, as Joseph said, all the value around security, the trusted platform, enterprise grade, manageability, etc., you get that on all of these things that are built in. And finally, accelerating the performance. And this is truly the innovation here, where all the code, all this deep learning based code that uses GPUs can be hosted natively inside SQL Server to produce these intelligent applications. Thank you.
Thank you, Rohan. Isn't that amazing? R, Python, deep learning with CNTK, with TensorFlow, arbitrary Python libraries and like OpenCV, all of that integrated into the industrial strength relational database management system that is SQL Server. What you've just seen is the first commercial RDBMS with support for AI. And that deserves a hand. Now, with all of the investments that we have made in making SQL Server a powerful data platform, we have customers creating revolutionary applications, such as intelligent data warehouses. For example, there's Jack Henry & Associates, an independent software vendor, who's now transforming their industry with SQL Server as a real-time data warehouse, doing operational analytics and even predictive analytics with very low total cost of ownership. SQL Server 2017 combines the best of databases and AI and analytics into one product. Everything built in. So now let's switch focus a little bit to data platforms for building intelligent software as a service in the cloud. SaaS applications are being built today with incredible data scale. Applications such as online multiplayer games, mobile ordering apps, online retail, they require very low latency writes, multi-region databases, and flexible schemas. So Azure DocumentDB is a cutting-edge database designed for such ultra large-scale SaaS applications. In fact, it is the first planet-scale, globally distributed NoSQL database service. It is designed as a globally distributed database system from the very ground up, allowing customers to distribute their data across any number of Azure regions worldwide. So apps can serve data from a region closest to their users for fast, uninterrupted access. It allows customers to scale throughput and storage independently across any number of regions. These are all unique features, folks. It's low latency, and it's guaranteed to have less than 10 millisecond latencies on reads and less than 15 millisecond latencies on writes for 99% of requests. And it's the only service that allows comprehensive SLAs for data loss, latency, availability, consistency, and throughput. SLAs for all of those. It is indeed a truly unique database designed for rapid development of mobile and IoT applications. It actually gives you 4 well-defined data consistency levels to choose from: eventual consistency, session consistency, bounded staleness, and strong consistency. That's more power to the app developer. It has native support for SQL, for JavaScript, and MongoDB protocols. It's schema agnostic and is capable of automatically indexing data. So you can do very, very powerful querying of your NoSQL data. And it's capable of ingesting sustained volumes of writes and automatically indexing all that data without any manual index management. And finally, it brings analytics to all that data. It has seamless integration with Spark for advanced analytics. The Spark connector that we have built for DocumentDB, it understands the physical structure of the DocumentDB store and enables computation pushdown for efficient processing. So now let's hear from a customer using all of that power.
Domino's main customer demographic consume technology on a daily basis. It's part of their life. They have very little tolerance for solutions that don't run well or don't run at all.
We had experienced an outage in the past which has taken down ordering globally. Choosing DocumentDB gave us capability to regionally distribute data and to scale the database easily. It's very easy to provision.
Because the peak periods are so valuable to our business, we really strive to maintain a 99.99% uptime. On the Azure platform, we can fail our traffic over to complete other countries. Whether you're ordering a pizza in Australia or Japan or over in Europe, you can rely on the DocumentDB performance. Even with the global scaling, we can still rely on that millisecond low latency. Serverless computing for us is really handy in moving our data around. We know what Azure functions, so it's infinite scale, so we can move as much data as we need.
We basically rely on data to make all our decisions. It drives our strategy, our campaigns. It's essentially providing a view to the outside world. We had a particular requirement with Europe to keep our information encrypted. SQL always encrypted is very important. We use that actively to ensure security of all our customer data. With Azure, it's opened a whole new ball game. We've got Azure Data Warehouse to deliver more insights to the business.
We don't have to worry about outgrowing the platform or having tools that are dated. We know that Azure is always going to be at the cutting edge of any cloud technology.
Domino's is a company that never wants to be ordinary. We want to continue to develop and deploy meaningful tech, to continue to grow and expand the business, and we're willing to put our trust into Microsoft.
Azure provides an end-to-end platform with an integrated and comprehensive set of tools and services to help you build intelligent applications. We call it Cortana Intelligence. It integrates services for information management, big data, machine learning, AI, a bot framework, and business intelligence all together. The best way to understand what's possible with all of this power is to walk through an example of an AI application built on the cloud. So let's look at an example of a next-generation AI-powered customer service application. AI has the potential to significantly improve customer experience in service situations. Not only can customers get instant, high-quality responses to their questions and needs, but by learning from vast amounts of historical data, AI systems can anticipate problems and head off customer churn. So let's see all of this through a demo. Let me invite Daniel Dean, our Senior Data Scientist Lead, on stage to demo this intelligent customer service application. Danielle?
Great. Thanks, Joseph. So I have some super exciting news to share today. I might be being selfish because the news I have to share is I bought a car. So I bought a car yesterday. Now I need to get insurance for this car. So let me actually browse to the website of my insurance agency and actually go about trying to purchase an auto policy. So here I see a live chat. So there's a bot that's available to actually speak with me to help me understand how I can buy an auto insurance policy. Now, bots support a lot of different patterns of interactions with our customers. We actually have a translator API that's working here where it can actually detect the language that I'm typing in and automatically write back in the appropriate language. Now, we can do some basic things like question and answer. So we ask, for example, where are you located? Now, the bot is going to understand the intent of what I'm saying, no matter what type of phrase that I actually use. So now I obviously came here to buy insurance, so let's go ahead and do that. Insurance. Now, this actually uses LUIS, the Language Understanding Intelligence Service, to actually understand the underlying intent. If I had said I want auto insurance, it wouldn't have actually asked me what type of insurance I want. So here, it actually asked me, I want auto, and it's now going to walk me through trying to actually authenticate if I'm an existing user or not. So in this case, I'm going to say, yes, I am an existing user. And what it's doing is it's actually connecting back to dynamic CRM to gather customer information and put that back into the framework. So here you could actually do smart authentication, things like facial recognition or voice recognition. In this case, I'm just going to do a simple personal identification number. And again, it's connecting back to that dynamic CRM to gather information about me. Now, after it authenticates me and it connects to all those systems, it's going to ask me more details about what kind of car I have. So I'm going to walk through and say I bought a Ford, for example, and I bought a Ford Fusion. It's a pretty exciting new car. And you also see that not only can you interact with the bot through typing, you actually have some nice options, some cards that display really nice little buttons here. And so it's actually going to ask me to upload a photo. I'm going to do that quick. Upload a photo here. Oops. So here I didn't pick the car. I actually picked a picture of my dog, and it says it looks like more like a dog standing on a field. I'm kind of disappointed it didn't say it was the most beautiful dog in the world, but I'll take it. So here it's really nice to be able to use the computer vision APIs. It actually detects what's in the image, making sure it's something appropriate if in this case. So let me do this right this time. So I'll get my Ford Fusion picture. And now the bot is actually going to understand that picture and actually try to build an appropriate quote for me. Now, in this case, it's not just going to use traditional risk assessment systems. It's actually going to use things like Azure machine learning models to understand my underlying propensity for churn. So really enhancing what you can do with traditional risk assessment systems. So you see in this case, it proposes a policy for me. And now I'm going to react to that policy and say whether I want to use it or not. Now, if I like this policy, it'd bring me to the payment process, maybe even use an existing method that's already there. But in this case, I'm going to say, no, that's way too expensive. And now the bot is going to use the Cognitive Services Text Analytics APIs to understand the sentiment of that. And actually you're going to say, oh, you know, I can't actually deal with this as a bot. Let's bring in a human to actually help with this and help close that interaction. Now, as the human agent coming into this interaction, I need to understand what's going on, what is this customer information. Now, all of the information from that bot is going to be brought into Dynamic CRM, so you can see what the chat history is. You can see information about how long I've been a member at this insurance company, as well as getting information about the likelihood of churn with that machine learning model, as well as recommendations for what the human agent should actually consider. Maybe a discount in this case would make me less likely to churn. And so the agent actually has all of this information right at their fingertips to then go interact with that customer. Now, all of the information from these live chats are going to be hosted into CRM, but as across all of those different chats, you can actually aggregate that information and get even more insights on top of your data. You can actually do assessment in near real time to understand what trends are happening and what might be going wrong across your entire company. So for example, we can zoom in and look at some negative sentiment that's happening in Australia. And we see our word cloud says Contoso Insurance, expensive. This might indicate that our competitor is actually doing well in this market and our prices are too high. So with just this Power BI type of tool, you can actually zoom in and look at all of that information available to you. So what I've shown you here is the bot framework, how it enables you to have a really natural, personal conversation with your customers, interact with them, and then you can enhance that with machine learning and visualizations to really make the most value for your business. Thank you.
Let's now talk about the second theme, trust. It's simple. You should trust our data solutions to keep your data safe. You should trust our platforms to grow with your needs and never limit you in scale. Two key things that we promise our customers. So first, let's talk about keeping your data safe. You own your own data. With Azure, you have ownership of customer data, that's text, sound, video, or image files and software, and we guarantee that all of this data is secured by our data platforms. You are in control of your data. We conform to global standards. Azure meets a broad set of international and industry-specific compliance standards, such as ISO 27001, HIPAA, FedRAMP, SOC 1 and SOC 2, as well as country-specific standards like Australia IRAP, UK G-Cloud, and Singapore MTCS. And second aspect of trust, you can trust us to grow and scale so that your cloud services have no limits on headroom. With every iteration and release of our products, we continue to improve our capabilities to ensure that we keep your data safe and that our infrastructure can grow with your needs over time. And now we are embedding advanced capabilities like machine learning directly into our cloud services to deliver intelligence to keep your data safe. For example, consider the security features in Azure SQL Database. Our ML systems behind the scenes of SQL Database today analyze and learn from over 700 terabytes of data per day to ensure we keep your applications highly efficient and safe through automatic auditing and threat detection. With active threat detection, the Azure SQL DB service can now identify anomalies in your workload and can alert you of potential attacks like SQL injections. And the service does the hard work, so you don't have to. So you can focus on business problems you're solving and creating breakthrough applications. In addition to automatic threat detection, SQL provides an alternative with SQL authentication. It simplifies password management by allowing you to connect to a number of Azure services, including Azure SQL Database, using the same identity. It allows access to rows of data based on a user's identity, role memberships, or even query execution context. That's powerful. It lets you define masking patterns on database columns to limit the exposure of sensitive data. And all of these are features that ensure that your data is the most trusted it can be when it's in a database. So let me show you how easy it is to turn on auditing and threat detection in Azure SQL Database. We are making it extremely easy for you to use the power of machine learning for automated auditing and threat detection. It's extremely easy to enable. All you have to do is go to Azure Portal, simply select auditing and threat detection in the settings blade. Then turn on auditing and click Save. With 3 clicks, you're automatically using machine learning to detect anomalous database activities. In the case of any anomalous activity, you will automatically receive an email notification. The email will provide information on the suspicious security event, including the nature of anomalous activities, the database name, server name, and the event time. In addition, it will provide information on possible causes and recommended actions to investigate and mitigate the potential threat to the database. We are making it extremely easy for you to use the power of machine learning for automatic auditing and threat detection. Not only are we making our services smarter and safer for you, we are also building data services to enable you to build globally scalable applications with extremely low latency. So what we're doing is using machine learning to deliver unparalleled performance. It's a learning database that automatically analyzes queries, automatically indexes, and tunes the indexes tailored to each workload so your performance constantly improves. We can use AI to auto-index your data so you don't have to. Our databases are also built to scale for the most demanding applications, leveraging the incredible global scale of Azure. For example, Azure SQL DB now allows any SaaS application to achieve unlimited global, read scale with chained geo-replication. Azure SQL DB supports self-service activation in all service tiers. And you can set automatic failover policies. And you can replicate data to any Azure region, allowing you to serve read queries for these ultra-scale software as a service applications from multiple regions globally. So your applications have plenty of headroom. Let's now talk about the third theme, developer flexibility. Our customers want flexibility when it comes to the choice of the platform, programming languages, and data infrastructure so that they can get the most from their data. Customers want the flexibility to deploy anywhere, on-premises or in the cloud, the flexibility to use any type of data, even querying Hadoop systems and handling JSON data. They want to be able to run on any choice of OS, on Windows or Linux, or even in Docker containers in Linux, and use open source, such as R and Python, to program analytics and AI. And finally, any type of application, Java, Ruby-based, Python-based, should be able to efficiently use the database. And SQL Server provides all of these. It is truly a platform for data-driven intelligence. Today, we are also announcing the release of R Server 9.1, adding to that flexibility. It is a standalone analytical platform that can be deployed anywhere your data lives. It comes with SQL Server when you buy SQL Server, but it also supports Hadoop, Spark, and Teradata in addition. There are some very exciting advances for machine learning and AI in this release of R Server. It is scalable R-based machine learning, algorithms from Microsoft, made scalable and parallel. It now has a pre-trained collection of cognitive models for analyzing text and sentiment. It even supports GPU. You have GPU-powered deep learning. All of these are now available on both Windows and Linux. It's a unique enterprise analytical platform that combines the best of open source and proprietary source. We've shared a lot of exciting product capabilities today. Now, with the power of the cloud, it's never been easier for you to get started building your intelligent SaaS applications. As we have worked with our customers, we have identified the most common patterns for implementing big data and advanced analytics applications. And we have now codified these learnings into predefined reference architectures to make development simple. We call these solution templates. Cortana Intelligent Solution Templates, now available, they provide reference architectures for common ways of combining multiple services on Azure. It's built on best practice design patterns. It's based on real-world customer implementations by our engineering team. And the value is incredible. It accelerates the time to value for an intelligent application building to deploy a complex architecture. And you can do that now in minutes instead of days and weeks. It's flexible and scalable. And these solution templates, you can customize them. You can customize them to your specific needs, and it's even backed by a rich partner ecosystem. It can be deployed in your Azure subscription, where you can bring even other pieces and scale these up and down. So today, three new solution templates are available, and they look like this. These are a collection of services that are connected together. And the three things that are available today are personalization, demand forecasting, and quality assurance, with many more to come in the future. So I started out this conversation with what drives us. Solving big problems such as understanding the universe, solving cancer, and making the world a more sustainable place for all of us These problems are now becoming tractable with our data platforms. The investments we are making in our data platform are helping take science and technology and software to a completely new level. So let's step back a bit. In 1769, James Watt invented the steam engine. It kicked off the Industrial Revolution that transformed the world in the subsequent decades. The steam engine of today is the intelligent cloud. It is kicking off the intelligence revolution, which will transform the world in the next few decades. It'll be one of the most exciting times in human history. Thank you.